Okay, here we have a football player tackling another football player, and let's see. So we have a big one and a small one. I'll just draw them as like pucks or whatever, because it's easier. So the lighter player was running this way, so I'll call that U2 of 6 meters per second. I'm taking positive to the right, and the tackler came up from behind him, which means that the tackler was going faster. So I'm going to back this up so that I can draw a faster initial velocity vector. So that's initial. And then finally, they're like sticking together. And our VF is 6.84 meters per second. We want to know how fast the tackler was running. So if we make an if chart to see what's happening here, see the big one was running faster, the small one was running slower. Afterward, they're both moving the same speed, but that speed has to be between the two. It has to be slower than the initial of one and faster than the initial of the other, so that we have the same area here. So, assuming that momentum is conserved, we can use this if chart to write an equation. So mu1 plus mu2 is going to be, I'll call this one object moving at velocity vf, and I want to find u1. So I'll bring that over. So we have the 160 kilograms times the final v, which is 6.84, minus the smaller m, 70, times its initial v of 6 meters per second, divided by the 90 kilograms, which gives us 7.49 meters per second. So definitely faster than the other one. And to do this whole thing, I said we're assuming that momentum is conserved. We're assuming that there's no net external force on the system, which is actually a bad assumption. So we're saying in particular there's no like ground foot forces horizontally. If there were some vertically, it wouldn't matter. They'd probably balance out anyway, but even if they didn't, you can do conservation of momentum in one dimension but not another. So we're saying that like the tackler and the runner are not pushing against the ground while the tackle is happening. Like they're trying to, like the tackler running faster, pushing into the ground to kind of hit the guy harder. That would mean that momentum is not conserved. So we have to ignore that if we want to do this analysis.